you very much, Demetra, and thank you for inviting me to speak today. So I'm going to talk a bit about some of the challenges that there are in research as a telecoms company. So I'll tell you a bit about who BT are, and what we do, and a little bit of our history. Then I'm also going to talk about some of our challenges and a little bit about some of the research that we're doing to try and address those challenges. So just to start with, oh, has that worked? Yes. Who are BT? So we are the UK's largest telecoms company. We have the largest fixed and mobile network in the UK. We're a FTSE 100 company, but as well as the UK, we operate in around just over 180 countries around the world. And we sell fixed and wireless services and also TV now to consumers in the UK, to enterprises of all sizes in the UK and government, and also to multinational companies through our global division. So you can see a bit of our structure there. You might not be aware of all of our brands. So we obviously sell things as BT, but we also own the EE mobile brand, and we also sell services through the PlusNet brand. So that's a bit of a history about a bit of who we are. And a bit of our history is that we are, in fact, the world's oldest telecommunications company, and we can trace our origins. Slides aren't working. There we go. We can trace our origins back to a patent that was filed in 1837 by these two gentlemen here. They are William Fothergill Cooke and Charles Wheatstone. So many of you I know will be engineers, so will be very familiar with Wheatstone and the Wheatstone Bridge. William Fothergill Cooke we would probably call him an entrepreneur now, or sort of a businessman. And they were contemporaries at the time of Michael Faraday, who was making his discoveries around electromagnetism. And they were very excited about this. And they filed a patent to cover an electric telegraph. So this is the first time that communication at a distance was possible without somebody taking a message, on a horse or something that had been written down from one place to another. And you can see their example of their electric telegraphs in the Science Museum in London. And after this, the Fothergill Cooke set up something called the Electric Telegraph Company in 1846, and we can trace BT's origins through the post office right back to that time. And purposeful innovation, which is really what they were all about, which was taking some discovery, some breakthrough science, a bit of practical engineering to make it work, and then using it for a purpose, which in this case was communication. That's what we mean by purposeful innovation, and that is something that has stuck with us all the way through. So all of our research and innovation work that we are doing is all very much about taking that breakthrough discovery science, often working with universities like the University of Bristol, applying some of that practical engineering know-how to it, and using it to solve a problem that people are having. And just to kind of give you a flavor, and I won't go through all of these, just some of the kind of key milestones going back to 1846 along the road right up to today. So just picking a couple of those out. So in 1926, that was the first two-way transatlantic telephone call. So that was the first time a human in the UK had spoken in real time to a human in the US. And it was a radio, so I guess you could say it was a mobile call. And that was in 1926. A couple of other examples. So many of you will be familiar with Colossus, the world's first programmable electronic computer. That was invented by Tommy Flowers at Bletchley Park. Tommy Flowers was actually a post office engineer, so he worked in the forerunner of what is now BT Labs. And he invented that to support Alan Turing and his team, who were working on cracking the cipher, the Enigma cipher, and the Lorenz cipher from the German, with the capture from the Germans. And historians tell us that brought forward the end of the Second World War probably by about 2 years. Coming a bit closer up to date now, so 1984, this was the world's first use of single mode optical fibre as a link. We didn't invent single mode optical fibre, but BT were very much responsible for engineering it to make it into something that was practically manufacturable and usable. And in 1984, we had the first link between the two illustrious locations of Luton and Milton Keynes. They were the first two places in the UK to be linked in this way. And then coming right up to date, obviously 2019, BT through EE were the first provider of 5G in the UK. And that, again, was not in no small part to work we've been done with universities, and also particularly with the University of Bristol. So that's to give you a flavour of some of our history. A bit about our research and development. So we are a research-intensive company. We have our own labs. I'll say a bit more about that in a moment. We are research-intensive in that we file patents, we write papers, we're attending some of the kind of conferences that many of the academic community on this conference today will be taking part into. So We have around 30 direct university relationships around the UK. 4 of those are strategic partnerships, and I'm pleased to say one of those is with the University of Bristol. Over the past 5 years, we've spent sort of about £2.8 billion on R&D, and we are the 4th highest patenter with the UK Patent Office in terms of UK-based companies, and we are the biggest applicant in the UK for AI patents, and that includes both academic and industrial organisations. So that includes all of the universities. So that's an area that we've been very, very active in. I mentioned we have our labs. This is where they are. This is Adastral Park, which is in Suffolk. It's also our UK operations centre where we manage all of our networks. It's the largest test and integration facility in Europe. We have enough telecoms equipment, I'm told, to run the Belgian telephone network in one of our facilities. And it's a real national centre that brings people together to innovate and to research digital and communications and the future of those technologies. It's normally, when it's not a pandemic, home to about 4,000 people. Around 2,500 of those work for BT, 500 for Openreach, and the other 1,000 work in our innovation Martlesham cluster. So that's a cluster of different sorts of ICT high-tech companies who have chosen to base themselves with us and for mutual benefit. And that varies from multinational companies that you will definitely have heard of down to kind of one person and their dog startups who are also in the space. We welcome many visitors during normal years, in particular CEOs of some of the large organisations that we work with, influencers like government. We've had a cabinet meeting at Adastral Park, and we also welcome sort of 6,000 to 8,000 school visitors a year, because bringing on that next generation of technologies is something that's really important to us. And just to give you a flavour of our presence around the world, we've obviously got Adastral Park, but we also have research centres in MIT in the US, Belfast, in Abu Dhabi, in India, and also in China. So they are much smaller centres, but an important part of our kind of global network. Okay, so what are our research challenges? And I think the best way to describe the main overarching theme of all of our research challenges is just, I would say, the relentless pace of change. So nothing stands still, things keep changing, and the pace of that change is going is ever increasing. It's getting faster and faster, and we need to be in a position to react to that and to adapt to that. So if I just take as an example, thinking about mobile connectivity. So 1985, first generations of mobile phones. If you saw one, you were probably kind of chin on the floor in wonder at this amazing thing that meant you could make a call from anywhere, from anywhere that you were, provided there was connectivity, of course. And we've now sort of 35-ish years later, we are in a position where wireless connectivity is essential to, all aspects of our lives, and people just expect to be connected wherever they are, whether that be, in a city centre, up a mountain, at home. And so maintaining that connectivity, maintaining the requirement, the hunger for bandwidth is something that's a big challenge, because one of the themes of this is, although our customers have higher expectations, they want faster speeds, they want lower latency, they want a better experience, they don't want to pay more for it. So we can't double the speed and double our prices. That just doesn't work. Our network traffic growth is another interesting area. So this is traffic on our kind of core fixed network over a period of time. Now, you'll see there is a general trend upwards here. So the sort of compound annual growth rate on our network traffic is about 20% per annum. And this graph here shows the daily peak. And this is measured in 15-minute intervals. And typically every day the peak is around 9:30 in the evening, when people are often, at home, they've finished work, they've had dinner, maybe they're streaming some content online, maybe multiple people in the house are streaming things. So this is where we see these peaks. So you'll see there is a general upward trend, but what you will also notice is that it's incredibly peaky, that we have these really high peaks at particular times caused by particular things. And the challenge here is that we need to make sure our network is able to cope with those peaks. So the general trend for growth is one thing, but understanding when those peaks are likely to occur, and in some cases where they are likely to occur, is something that we're constantly looking at. So what causes those peaks? You can see some of them are labeled. They tend to be big streaming events or big new releases of things. So for example, games like Call of Duty and Fortnite, when there are new releases of those, lots of people will go on at the same time to download that, to stream that, because they want to have the latest version. We also see big sporting events, particularly if they're made available free, they have quite a big impact. So you'll see in sort of December time, Amazon have a deal at the moment where they stream some of the Premier League football matches for free in the UK at those times. And so you see that causes enormous peaks on our network. And the nature of those peaks can actually also be geographical. So what you might find is that, let's take an example of a football game between, say, Liverpool and Everton. That would cause an enormous peak on the network in sort of in the Merseyside area, but might have a bit less of an impact around the rest of the UK. Whereas a game where perhaps Manchester United were playing, because they have much more of a following spread around the place, that would cause a peak across the whole country. So we need to be aware of these things, be mindful of them, and be working to provision our network and expand our network in a way that can support them. And I should say it's not all sport. The Great British Bake Off, and when that becomes available for streaming, is also something that causes quite big peaks on our network. And just one final thing to talk about in terms of the challenge, and that is the changing face of the competition. So I'm sure if we're in a room and I asked you to put your hand up, how many of you recognize the logos of the companies on here? I'm sure you all would. I'm pretty sure you're all using at least one of them now, if not multiple ones of them, or you have perhaps in the last 24 hours. So we're in 2021. These are examples of companies whose services drive a lot of traffic on our network, but they don't necessarily they're not necessarily paying us for that traffic. The end customer is paying that company. It just happens to be traveling over our network. And if you just have sort of go back in time and look at what happens, if we go back to 2010, so 11 years ago, some of those companies that we use and take for granted now didn't exist. If we go back just another 5 years beyond that, again, we start to see that, again, quite a number of them didn't exist. If we go back to 1997, so that's, not quite 25 years ago, much smaller group of them existed. And in fact, if we go all the way back to 1975, only one of them existed at that point. But my point here is that new companies are coming along all the time with really innovative services that drive traffic on the internet, that drive streaming services, that might drive video services, which use a lot of bandwidth. And we don't always see them coming, and that can be quite challenging, and trying to anticipate what might be coming around the corner, the kinds of things that people might be wanting to do, and how we then have to support that with our network. So thinking about us as a business, we are very much a connectivity business. All telecoms companies are in the business of connectivity, but what we're looking to do is move beyond just being about connectivity. Demetra talked quite a lot about trust, and absolutely, we want to be offering connectivity as a service, but that connectivity needs to be trusted. It needs to be that people trust that when their data travels over our network, that it's not going to be compromised. They also need to be trusting that when they're getting data coming over our network, that the person or the entity at the other end that they're getting stuff from or sending stuff to is who they think they are. And then the next layer above, moving above that, is into sort of actionable insight. We have lots of data traveling over our network, but the value is not really in the data. The value is turning that data into information which will inform, which will allow people to do something as a result, to take some action. And ultimately that drives productivity. So ultimately we're going from connectivity as a service into what we would hope would be productivity as a service. And there are lots of examples of different use cases in this space. So things like connected agriculture, using the Internet of Things, or lots of kind of potentially autonomous robots, autonomous drones in other sectors as well, like manufacturing, remote healthcare, and the challenges that there are there around trust and data, but also around making sure, for example, that the latency is at an acceptable level if remote procedures are happening. So there are lots of challenges there in moving into this sort of new world. So just want to move on now to talk about a couple of areas that we're actively working in to try and address some of those problems that I talked around. So the first one here is hollow core fibre. So this is optical fibre, which, as it says, has a hollow core. So the light is traveling through the air at the center of the fibre. And the properties of this mean that it is, there is less scattering, there's less crosstalk, and that's even at the sort of single photon level. And what that means is that potentially this could be a bit of a game changer. So this could lead to lower cost networks for us, because we can use more of the spectrum, for example. The low thermal sensitivity means that it has really particularly good applications in things like timing. The ultra nonlinearity makes it particularly particularly good potentially for quantum applications. So we've been evaluating some hollow core fiber from a startup company called Luminosity, which is from the University of Southampton. It came out of the University of Southampton. And you may have seen in the past week or so, we made an announcement of our world's first trial of using hollow core fiber for a quantum secure communication. So that is the data and also the single photon encryption key traveling over the same fiber, which using normal equipment that we've been using to do that over regular optical fibers. So that's very, very promising in terms of lower cost connectivity, but also lower cost, very secure connectivity. Another example, again in the quantum space, so this is using normal optical fiber, regular optical fiber, we've been exploring using quantum key distribution over optical fiber as a way of securing data. And we last year, during the lockdown, but we still managed to do it, we did the world's first industrial quantum secure network, which went from the National Composite Centre, which is very close to the edge of Bristol, to the Centre for Modelling and Simulation. And that happened over a regular optical fiber, which was already in the ground. This wasn't in a lab. This was real fiber under the ground with cars going over it and all of the other challenges that you get using things in the field. So we demonstrated that was possibility, and this could be a real game changer in many sectors, particularly high value manufacturing, where the transmission of data is something that's raises lots of concerns, where in some cases the data can't actually be transferred electronically over a network link. It has to be done physically by putting it onto some kind of storage device and a person taking it from place to place, such as the sort of sensitivity in some cases of perhaps of the designs in that kind of industry. So again, potentially a game changer. We've proving that this can work over already installed fiber. And final area I wanted to touch on, and again, it's one that Dimitra talked about, is AI. So if you know about networks, which I know that pretty much all of you will, we know that software is transforming networks. And if you know about software, well, AI is transforming software. And really how companies, organizations can harness AI for improving productivity, for optimizing how they use resources, be that people, energy, things. It's going to be what sets potentially organizations apart in the future. And we are a massive organization. We are a massive operation, just to give you some stats appearing here, just to give you an idea of some of the scale. And we are applying those AI technologies that we talked about, many of which we have patents in, to really optimize and transform the way that we manage the network in BT. And we're doing that in lots of different areas. I mean, one example would be we have 30,000 field engineers who drive around in vans, fixing faults, deploying things to our customers' premises. And we've been able to optimize using AI over a number of years. We've been able to optimize the way they are scheduled, ensuring we get the right person to go to the job, that they've got the right skills for the job, they've got the right equipment they need to do the job, optimizing the journey, the route that they take to reduce carbon emissions. And we've been able to make it so that our engineers can actually in the realm of hundreds of thousands of extra jobs a year by making just this more efficient kind of scheduling happen. We're using AI to predict what might happen in terms of looking at scenarios for big decisions that we might need to make as an organization. We're using it to predict where we think faults might occur, to diagnose faults. We're using it in many different ways, but there are still lots of opportunities open that we know that where we could use AI, and again, harnessing that in the right way and doing it in the right way and making it really work for us is one of our big challenges. And just to touch on, because people often ask, well, are you going to replace people with AI? And I think they're probably in the best thing to think about this is, if you're into the movies, is to think about Iron Man versus the Terminator. So in many cases, AI, but keeping the human in the loop, is the best way of doing things. So you kind of augment that person a bit like Iron Man when he puts his suit on. You make that person better at their job, rather than the Terminator as an AI entity that comes and takes over. So with that, thank you very much, and I will happy to take any questions, Maria, if we have time.
Thank you very much, Carol. Wonderful talk. And really, every time that you mention the work that you're doing with Bristol, I feel proud that we are able to contribute to your story. Thank you. Thank you very much. There is a question in the Q&A from Hamid. He said, you mentioned the over-the-top service providers are forming over decades and benefiting from the infrastructure that EE and BT has invested in reference to the recent Ofcom review of the network neutrality, is there a need to see a balance here?
Yeah, I mean, I think yes, and we are working with many of those, over the top service providers to try and do things as sensibly with them as we can, because obviously if our network's not working for them, then that impacts their customer experience. So doing things like, for example, caching content at the edge and thinking about where they're where whatever it is that they're streaming might need to be stored, or doing things in smarter ways. So yes, it's a tricky area, and I think there's multiple ways that are going to be needed to solve that problem.
Thank you. Any other question for Carol? Okay, I mean, also may I remind you, there is another question popping up. I'm not sure.
I'm scrolling down.
From Hillary, what are the challenges in keeping up with revenue despite infrastructure upsurge?
So that's an enormous challenge. So I mentioned that we can double the speed, double the capacity, but we can't charge our customers double. We can't put 20% on the broadband prices every year to kind of keep up with that growth rate. So it's an enormous challenge, and particularly that I think as the kind of connectivity becomes it's a utility, it's what people expect, and I think that people will see it as they won't have a propensity to pay a lot more for it. So the challenges we have are doing things as efficiently as we possibly can. But I think the other challenge we have is really innovating some exciting new services that run over the network, and using that as a way of driving revenue that will help to also support the network investment that we need to make in the infrastructure.
And just one last question, Carol. I'm not going to take another one. So that is about the hollow core fiber. And what do you think the rollout of the hollow core fiber will
when will
be?
That happen?
I suppose this is timelines, yes? And probably where and when?
We're still, it's still in the lab. We only started evaluating it in the lab this year, so it will be a good number of years. I suspect it would probably be in the core network first, but I have to say that's my thought on it. That's not any kind of official policy. So I don't think we've made that decision yet.